Hello everyone, we are a team from the Institute of Information Engineering at the Chang Academy of Sciences. Today, I will introduce our work in the field of mobile app security. The title is DARKFLEECE, Probing the Dark Side of Android Subscription Apps. Subscription is a type of selling model that allows developers to sell content service through recurring billing. To attract users, developers often set up a free trial before the purchasing. By September 2023, the number of subscription apps has exceeded 1.17 million, accounting for 13% of all mobile apps, and the annual revenue has surpassed $14.5 billion. However, a new type of scam apps, fleeceware, has also become prevalent. Fleeceware refers to apps that charge an excessive subscription fee after a brief trial period. There have been many reports about fleeceware. In 2021, the discovered fleeceware had over 600 million downloads, and the annual revenue reached $400 million. App market primarily relies on design requirements to prevent the emergence of fleeceware. It requires that subscription UI clearly and explicitly display important information, as illustrated in the right figure. However, these requirements are not sufficient, and the manual review of apps is still required, which is time-consuming. Currently, there's no clear definition of fleeceware, and the few researches are about what features can clearly distinguish fleeceware from benign apps. On the one hand, fleeceware doesn't contain malicious code, and on the other hand, its functions and behaviors are almost similar to those of benign apps. To address these issues, we need to answer the following questions. How to define fleeceware? What are the common features of fleeceware, and how to automatically detect fleeceware? To solve these problems, we designed DARKFLEECE. First, we construct the fleeceware feature library based on user comments, expert domain knowledge, and the literature on dark patterns. Then, we extracted these features from the app subscription UIs and trained the model to detect fleeceware. To help users better understand the fleeceware issues, we also use an explainable AI techniques to explain the risky features on the UI. I will introduce the key components in detail. To gain a deeper understanding of fleeceware, we first analyze user comments about fleeceware. The comments suggest that fleeceware uses common strategies to keep users unaware of or mislead about subscription information. By executing fleeceware samples, we also found that subscription UI design violates the app market requirements. They use various tricks to hide or ambiguously present subscription information, which can mislead users. Through further analysis, we discovered that the tricks they use are actually dark patterns. So, in our paper, we define fleeceware as apps that use dark patterns to trick users into subscription. Combining the requirements and the features of previous dark patterns, we summarize 12 types of risky phenomena in fleeceware. Then, for each phenomenon, the experts extract the relevant entities and attributes, formalize them into 19 features. And here are part of the features. Then the next step is to accurately extract these features. The features are all related to specific text on the UI, and the text is often fragmented. As shown in this figure, the yearly and the corresponding price are split. And in addition, the subscription information is expressed in multiple formats, such as yearly, some dollars, or some dollars per week, per year. So to address these challenges, we first design a layout-based approach to link related information. We observed that in a layout, All content-related widgets are defined under certain structured widgets, such as view group or linear layout. And in this figure, the yearly and the price are defined in a text field, and these text fields are defined in the same field group. So we can search for such structured widgets and link the fragmented subscription information. Then we analyze plenty of subscription information and summarize the common patterns for each type of information, such as specific keywords or symbols and particular expressions. We can use these patterns to extract the desired information. Using these two methods, we can obtain the target text information. But our features also contain many visual information, such as the font size, the visibility. So during the dynamic execution of apps, we can get coordinates information of each widget, like the information in the right figures. Once the text information is identified, we can use this to locate and capture the target area. Then we use OCR or other edge detection techniques to get the visual information. Finally, we try a decision tree model to identify which combinations of features are likely to deceive users. On the one hand, most of our features values are Boolean. Using a shallow decision tree model helps prevent overfitting on the small dataset. And on the other hand, the decision tree model offers good interpretability, making it easier to review the results. Finally, to help users to better understand the fleeceware issues, we apply SHAP to visualize our results and give alerts to users, as shown in the right figure. Our labeled dataset, DARKFLEECE achieved an accuracy of 93.43% in identifying fleeceware UIs. And for each app, DARKFLEECE only spent 7.17 seconds analyzing each UI. To understand user perceptions of fleeceware and our results, we conduct a user study. The results show that 81.8% of participants have previously encountered similar issues. And those without a computer science background are more likely to be deceived. Our results help an average of 13.51% more people notice the fleeceware UI issues. When applying DARKFLEECE in web apps, we find that 443 apps contain a total of 629 fleeceware UIs. These apps have collectively been downloaded over 5 billion times, and some apps appear on various top lists, indicating that fleeceware are prevalent. We further analyze the common strategies used in fleeceware UIs. The most frequent strategy is that the UI doesn't clearly inform users that it is a subscription. Instead, they emphasize the free trial. The second most common strategy is that they doesn't inform users that the subscription will be auto-renewed. And another prevalent strategy is the inconsistency between the claimed free trial period and the deadline of canceling the trial. We also explore the evolution of fleeceware in recent years. We find that fleeceware issue has indeed improved in these years. However, some developers continue to use dark patterns in their apps for profit, leading to the emergence of new fleeceware. In conclusion, we construct the first UI feature library for fleeceware detection. We develop a novel technique for efficient subscription information extraction. We assess the prevalence of fleeceware throughout the app market, and we investigate developers' evaluation and the user perceptions of fleeceware, offering valuable insights to solve the fleeceware issues. Thanks for your listening, and this is my email address.